class 12 science. In our last class, we're discussing about the chemical reactions of aldehyde and ketones. And in that, we discuss about this topic, that is oxidation reaction we have studied. And in that, we have seen what is haloform reaction. After that, we came to know about what is Tollens test. Then we came to know about Felling's test in the oxidation reaction. After that, we have seen reduction to alcohols, how we can reduce aldehyde and ketones to alcohols by using reducing agent. And after that, we have seen the reduction to alkenes, the very important two naming reaction known as Clemmensen reduction and Wolff-Kishner reduction reaction. So this topic we have seen in our previous class. Now today we are going to see a very important reactions of aldehyde and ketones. You can star it, you can mark it as 5-star because this is very important. Aldol condensation, and after that we'll study about cross aldol condensation. So it is a base catalyzed reaction. That means over here we'll be using a base, either sodium hydroxide or potassium hydroxide. So before going to understand the aldol condensation, we have to be clear about the alpha hydrogen. What does alpha hydrogen means? As you remember, I have explained about this in the physical classes, that if you have got a functional group, so over here we have got the functional group as carbonyl. It can be either aldehyde or ketone. So the carbon atom that is attached to the first functional group, the carbon atom which is directly attached to the functional group, is known as alpha carbon atom, and the hydrogen attached with it is known as alpha hydrogen. And alpha hydrogen are acidic in nature. That means they can be removed as H plus ion. That means if there is a base present, so from the base OH minus can take that H and form water. So because of this presence of this alpha hydrogen, we have got two important reactions. One is aldol condensation and other is Cannizzaro reaction. We'll see after this in our next video. Now, so we understand what does alpha hydrogen means, because in aldol condensation we need to know what is alpha hydrogen now. So over here what has happened, the bond has been broken towards carbon, so carbon will be negative. So since carbon is negative, here we have got a carbon-carbon double bond which can break towards the oxygen atom. So in breaking it, the oxygen will get a negative charge, whereas the carbon will have a positive charge. That positive and negative will form a double bond, and oxygen will get a negative charge on it. Now we'll go for the definition of aldol condensation then. So according to the definition, it tells us aldehyde and ketones having at least one alpha hydrogen, so it should have only one alpha hydrogen, undergo a reaction in the presence of dilute alkali. So over here the medium that we are using is dilute alkali, so it can be dilute sodium hydroxide or potassium hydroxide as catalyst to form what? Beta hydroxyaldehydes. Beta hydroxyaldehydes, which is also known as aldol, or beta hydroxyketones named as ketol respectively. This is known as aldol condensation. Beta hydroxyaldehydes, it's called as aldol. The meaning of aldol is it is a composed of two functional group. ALD stands for aldehyde and OL stands for alcohol. That means in this compound we have got two functional group, one is OH and other is aldehyde. Similarly in beta hydroxyketones we have got ketone. That means one ketone and one alcohol group. So this is the reaction for aldol condensation. So what we have done is we have taken acetaldehyde. So in acetaldehyde, if you see, this CHO is a functional group, so the carbon attached to it is alpha carbon atom, so hydrogen attached will be alpha hydrogen. So this aldehyde contains alpha hydrogen atom. Now if we have got such kind of aldehydes, when you treat with dilute NaOH, it will undergo a reaction to produce you 3-hydroxybutanol. 3-hydroxybutanol. Now how it is 3-hydroxy? Because 1 2 3, so at 3 we have got OH, so 3-hydroxy, and because of 4 carbon atom in a straight chain butane, and because of the functional group aldehyde, it is written as Al. and this is known as aldol. Why? Because we have got one aldehyde group and one alcohol group. Now, what will happen on heating? On heating, what will happen? This OH and one H from here, it will be removed as water, and it will form a double bond between these two carbon atom. So which will be known as but2enal, and this is aldol condensation product. Condensation means over here there is a removal of water. Now we'll try to understand the mechanism for this. That means how from these two molecules of ethanol or acetaldehyde it will form this aldol, and after that this aldol condensation product. Now to understand this, I have written once again the same reactions just we have seen. Okay, now here we have got two acetaldehydes. So first I have written only one acetaldehyde, and I have written its open structure so that we can see the bond breaking. Now, so as we know that this alpha hydrogen are acidic in nature, so the bond break towards the carbon atom. So the base will take this H and it will form water, whereas the carbon will have a negative charge. That means a carbon ion is generated over here. Now this carbon ion will combine with another molecule of acetaldehyde, because we have got two molecules of acetaldehyde. So what will happen? This carbon oxygen double bond will break towards the oxygen atom, and this carbon will attach to that carbon atom. So the structure will form like this. That means to this carbon this becomes O minus, and H comes over here, and this CH2 will attach to this thing, an aldehyde as well. Now after this we have added water, since water is reduced. So because of that, so this O minus will be neutralized with H plus and it form OH. Fine. So this will be aldol. Now this on heating, what will happen? This OH and H will be removed as water, and it will form a double bond, which is an but-enal. This is how the aldol condensation takes place. You can practice the mechanism as well by going step by step. Okay, fine. Now, so aldol condensation can take place between the ketone also. So over here we have taken propanol, or we call acetone. If you follow the similar mechanism like this, if you follow the similar mechanism in this way, you'll get this two product. You'll get this ketone form, which is 4-hydroxy 4-methyl pentane 2-on, and after that on heating it will give you the aldol condensation product. Now you can practice with the same mechanism and see whether you get this product or not. Okay, next, cross aldol condensation. When you talk about cross aldol condensation, it means that it is carried out between two different aldehydes and or ketones. So when there is a simple aldol condensation, that means we have taken the same kind of molecule. But when you talk about cross aldol condensation, over here you can have two different aldehydes. You can have two different aldehydes, or you can take acetaldehyde or propanol, then or you can take one aldehyde or one ketone. So that will be called as cross aldol condensation. Now, so over here we have taken two different products. One is acetaldehyde and this propanol. So we are considering the same kind of reactions, that is aldol NaOH. So first, if it undergoes self aldol, it will form this one. Just now we have seen. And if this compound undergoes aldol, it will form this one. Now, if there is a between these two compounds, so it can form the mixture of these two. So that means in cross aldol condensation there is a possibility of getting a mixture of two or more compounds. So in a similar way, go through the mechanism as I have explained over there and see how these products are forming. Now, based on today's class, your assignment number 3, what is aldol condensation? Question number 1. Question number 2, give the balance equation for aldol condensation along with the mechanism. So you first write down the balance equation and then write the mechanism, however I have explained over there. Then after that, question number 3, define cross aldol condensation. And question number 4, write the product of the following equation. So over here we have taken one acetaldehyde and one acetone, and we are treating dilute NaOH. That means it will undergo aldol condensation, and this is a type of cross aldol condensation. So you need to write down the product. Complete this assignment and send it in my mail.